Welcome to our discussion on class methods and relationships. Classes have four primary types of methods: constructors, accessors, mutators, and facilitators. These sometimes have different names, but they generally mean the same thing. Constructors build an object. It is their role to initialize all of the data in the object. Accessors provide access to the private data by returning a copy of that data. Mutators allow private data to be changed from outside the class, usually in a safe way to prevent errors. Facilitators perform other services for the class. Constructors initialize the object into a safe and usable state. Primitive data like ints and floats are initialized by the compiler, but that doesn't mean that these initial values are safe. For example, if we wanted to represent a month of the year, would 0 be a safe value? No, because January is usually identified by the value 1. There is no month numbered 0. Constructors also allocate any necessary internal memory using the new keyword. Constructors do not have a return value and have the same name as the class. If you don't define any constructors, the compiler provides a default constructor that accepts no parameters and does no work. Here we have built our own default constructor to initialize a day of year object to January 1st. Here we have a mostly complete day of year class with two attributes, a day and a month, a single constructor, two facilitators, input and output, two mutators, one that sets the month and day and one that only sets the month, and two accessors, one that returns the month as a number and one that returns the day. Let's take a look at these a little closer. Here's an improved version of the set method that checks the month and the day are both between the appropriate range before setting them. If one or both are invalid, this method returns false and sets them to a safe value. This is a good coding style to adopt, as classes should rarely interact with the console, as that limits their reusability for graphical applications. One of the constructors relies on this method to set the object to a safe value, so we have to make sure that the month and day are set to safe values before we exit. Here we show a facilitator input, which is used to ask the user for a month and day. This is one exception to the policy that classes should not interact with the console. In this case, we specifically want to. If we converted this to be a graphical application instead of a text-based application, we would have to rewrite this to handle other forms of user input anyway, so we have not lost anything. Here we ask the user for the month, read it in and store it, ask for the day, read it in and store it, and then rely on the set method to accurately detect any errors in the month or day, and since we are already using the console, we go ahead and report the error here. Here we see the other facilitator output, which converts the month into its string representation using a switch case statement. Notice that it has a default case to catch any errors in the month. While this shouldn't happen given the design of our code, it is a good policy to always catch all error conditions in case someone else alters our code and screws up these dependencies. Here we see a few examples of how to correctly use our new day of year class. We create 2 days of the year called today and Bach birthday. We then ask the user to enter today's date and then display it using our facilitator's input and output. We then directly set Bach's birthday to March 21st and display it to the user. Finally, if today is Bach's birthday, we display a birthday greeting to him. Otherwise, we display an unbirthday greeting. When designing your own classes, it makes sense to start with the data. What attributes will each object have that will be used to distinguish it from other objects of the same class? Then ask yourself what operations you will need to view and modify these data. Finally, what other methods might you need to manipulate the object? As a few good rules of thumb, data should be private, operations should be public, you will need at least one mutator and one accessor for each attribute, and you will need at least one constructor with a parameter that correlates to each attribute. Usually, as your applications get more complex, you will have many custom classes that must relate to each other in various ways. At the simplest level, those relationships are composition, aggregation, and association. We can use multiplicity to define a numerical relationship between objects. As before, these terms are somewhat poorly standardized, and you may see other developers use slightly different terms. Composition, or strong aggregation, is a relationship where one object is a permanent component of another. For example, a car really isn't a car without an engine. An engine is a necessary component of a car to make it a car. Otherwise, it's just a pile of junk or a frame. You may be able to swap out the engine or repair the engine, but it is still a necessary component of the car. UML uses a solid diamond to indicate composite relationships. In this example, the engine is a component of the car, so the diamond is next to the owner object. The directed arrow next to the engine indicates that the car has knowledge of its engine, but the engine does not have knowledge of its car. To implement this in C#, the car class will have a data member of an engine. Aggregation, or weak aggregation, as opposed to composition, is when one object is temporarily a component of another object. For example, a chair in a classroom may belong to that classroom for some time, but it could easily be moved to another classroom or out into the hallway. The chair is not a permanent component of that classroom, but helps define the classroom by the number of students who can take the course. UML uses a hollow diamond to indicate aggregation. Here, the classroom temporarily owns the chair. The absence of a directed arrow indicates that both the classroom knows about all of the chairs within it, and each chair knows which classroom it is in. To implement this in C#, the classroom class will have a data member that stores all of its chairs, and the chair would have a data member representing its classroom. If this temporary relationship seems odd, think about it this way. Does the classroom still exist even if we take all the chairs out? Our final relationship is that of association. This is truly a temporary relationship where one object only uses the other object for a single method. In this case, for a player to take his or her turn, he must throw the dice. For this game, the player does not have their own set of dice. They share the dice with the rest of the players. In UML, the association relationship is indicated by a dashed arrow that points to the class being used. To implement this in C#, the class being used would be passed as a parameter to a method in the other class. So here, the player does not have a data member of type dice, but instead accesses the dice temporarily as a parameter to the move method. We've already seen a few good examples of multiplicity, but this defines how many of one object owns or uses how many of the other object. Usually this is a one-to-one or one-to-many relationship, but there are a few other variations. Numbers are then added to the relationship in UML to describe the numerical relationship between these objects. In C#, a one-to-many relationship would usually imply that the owning class has a collection of the other class. So, for example, a classroom has 0 or more chairs, implying that the classroom would have an array or list of chair objects that might be empty.